This is an example of a recycle system for a non-reactive system. So the question is saying that seawater is to be desalinized by reverse osmosis process using the scheme indicated in the figure below. Using the data given in the figure, calculate the rate of brine waste removal, the rate of desalinized water production, P, and the fraction of brine leaving the reverse osmosis cell, that is recycled. This is the diagram that is given to us, and if you see here, this is our feed, 1000 pound per hour. The composition of our fresh feed going into the reverse osmosis cell is 3.1% salt, and the rest is water, and it will combine with a brine recycle to form a gross feed which has a composition of 4.0 salt, and then reverse osmosis process will happen where your water will be desalinized to produce P, which is our desalinized water, with a composition of 0.05% of salt, and whatever coming out, our gross product will be separated, will be split into a brine recycle and brine waste, which has a composition of 5.25 salt. Now let us see how we solve this question. First of all, let us draw back our process flow diagram. This is your reverse osmosis cell. You will have a fresh feed coming in, and it will be mixed. Okay, so we can put here a mixer with your recycled brine, and then this is your gross feed. Coming out from your reverse osmosis cell, you will have your desalinized water, P, right? And then your gross product or gross brine waste, which will be separated into your brine waste, which is B, and also recycled back to your feed. So this is your brine recycle. We can label it as R. So we know here this is 1000 pound per hour, and then the composition is 3.1% or 0.031 salt, and the rest is water, 0.969 water. This is your gross feed, so I can just label it here as G. So here I know the composition is 4% or 0.04 salt, and the rest is water, 0.96 water. And then coming out from your reverse osmosis cell, our desalinized water, P, which has a composition of 0.05% salt or 0.0005 fraction of salt, and the rest is 0.9995 water. This is our gross product, so I can label it here as our P1. Right? This is your separator, your splitting unit. And then your brine waste has a composition of 5.25. I can put here 0.0525 salt, and then 0.9475 water. So this is everything that we know about our system. Now, first thing that we need to do is that we have to identify our system. So you can see here, I can put here my overall system, meaning that my overall system is, I can label it like this. This is my first system, which is my overall system, right? I can have, so I can say this is my first system. I can also have a system just for the mixing unit. This can be my second system. So this is my second system. And I can have a third system for my reverse osmosis cell. This is my third system. third system. And my fourth system is for my splitting or separation unit. So this is my fourth system. You can see here we can have 4 different systems. Now it depends on us which system you want to use to solve for our B, P, and also the fraction of brine recycle. So in this case, I'll be using first of all my overall system. So I will solve this using overall system. So for the overall system, I can draw again my overall system. This will be my overall system. I will have my feed, which is 1000, and then my composition is 0.031 salt, and then 0.969 water. Coming out is my P, right, which is 0.0005 salt and 0.9995 water, and then coming out here is my brine waste B, which is going to be 0.05 0.0525 salt and 0.9475 water. Right, so this is my overall system, where inside the overall system I have a mixing unit, I have my reverse osmosis cell, and I have a separation unit with a recycle stream. So if you look at here, we have 2 unknowns and we have 2 independent equations, so we can solve for our P and B. So the overall balance will be 1000 is actually equal to P plus B. This is my first equation, right? If I were to do balance on salt meaning that I have 1000, my feed, times with the composition of salt in my feed is 0.031, is equal to P, which is my desalinized water, and the composition of salt in P is 0.0005, plus B is my brine waste, and my composition of salt in brine waste is 0.0525. So this is my second equation. So solving both of this equation will give me B is equal to 586.4 pound per hour, and then P is equal to 1000 minus 586, I'll get 413.6 pound per hour. So this is my value of P and B. The next thing is that we want to find the fraction that is recycled. So fraction that is recycled, if you look at our system, right? So this is our splitter, and then this is our recycle stream. So fraction of recycle meaning that this is our R value, right? This is our B, and then this is we label as P1. So fraction of recycle is actually equal to R over P1. And your P1 is actually equal to R plus B, right? Because whatever is going into the separator is coming out as one as your recycle and one as your brine waste. So we are actually trying to find the value of R, because we already know the value of B from our previous section of the question. So in order for us to find the value of R, we can either use our mixing point or our separation point. So for this here we have our mixing. We either use this system to solve for our R or this system, because these are the two systems where we have one is R going in, going out, and one R is coming in into the system. So to solve this one, I'll be using the mixing point here. So I'll be using balance at the mixing system. So this is our mixer. We have our fresh feed coming in at 1000 pound per hour. Composition is again the same, 0.031 salt, 0.969 water. We have our recycle R, and then we have our gross feed, and we label it as G. And the composition is already known as 0.04 salt and 0.96 water. So the first thing we need to understand about a recycle system is that if you look at our flowchart, the first one, it mentioned that if I were just to draw it here again, let's say this is your, from reverse osmosis, this is your P1, and then this is your B, and this is your R, right? Recycle that is going into your mixer. So if you understand, the function of a splitter is just to split the stream. The composition will be the same. So that I can say that since I know the composition in my brine waste, which is 0.0525 of salt and the rest is water, so I can say that this composition will be the composition for my P1 and also the composition for my recycle stream. Why? Because separator only separates your flow rate. It will not disturb your composition. So if we are using that logic, we can know that the composition in our recycle stream will be 0.0525 salt and the rest 0.9475 water. Now if you look at our completely labeled flowchart for our mixing system, we have two unknown, R and G, and we have two species, so we can make two independent equations. So basically we can solve for our R and G. So if we do the overall balance, G is actually equal to 1000 plus R, because G is equal to R plus 1000. And then I can do the same thing, I can do balance on my salt. So for G, I have 0.04 salt is equal to fresh feed, I have 1000 flow rate, (0.031) plus my R, and the composition is going to be 0.0525. Now this is my equation 1 and this is equation 2. Now solving this equation, my R is equal to 720 pound per hour, right? So now the question asks us what is the fraction, and then we already defined that the fraction is going to be R over P1. Just put here fraction recycle is equal to R over P1, and we know that P1 is basically P1 is R plus B, so R over R plus B is going to be equal to 720 divided with 720 plus the value of B, which calculated earlier was 56.4. So we get a fraction of recycled is equal to 0.55